Can someone start the live stream? Thank you. Don't forget to sign into the document. Post a link here. All right, any new faces? Anyone joining us for the first time or one of the first times and would like to introduce themselves?
Yeah, hi there.
Hey.
My name's Joey Brown. I'm a fairly new member to the Salesforce Heroku team. So I'm just kind of, I think this is my second meeting or so. So I'm just kind of joining in to get a feel for things.
Cool, welcome.
Thank you.
Hey everyone, I'm Laksh and I'm from India, and I'm a student. I'm a second-year student from India, and this is the second time I'm joining this meeting. So yeah.
Cool, welcome.
Thank you.
All right, release planning. Implementation team.
I'm not sure if there's much to say. We are working on the next platform and build pack APIs, and we'll have more updates in a little bit.
Cool. Platform team.
I know David had kind of put pack in RC mode or feature complete last week, so that should be going out this week. I'll follow up with him and make sure we're still on track for that.
Cool. No updates from distribution team, BAT team.
Nothing.
Cool. Did I forget any teams? Alrighty. I think we're ready to move on to the agenda. First one up is run image SBOM. I think that's Sam's. Did you want to take that one?
Yeah, I just wanted all the core team members who approved to take a look at my comments and request a review if you think those are appropriate. Otherwise, given our last discussion, that thing is an FCP. But I do think that if we merge it without those comments being addressed, we'll just have issues down the line.
You mean the comments from your review?
Yep.
Are you talking about? Okay. Should I recall the reviews for the core team? Re-request review?
I don't know how this works, but yeah.
I did mine for sure. So I'll take a look at it, and if I think everybody needs to as well, I will do that for the others. Okay, did you any discussion on it, or should we? Okay, cool. All right, the next one up is cosine PR 195.
Yeah, I think it probably goes along with a bunch of the daemon removal stuff, but I just wanted to bring up like what, or discuss what our timeline with all of these things would be, or like in what order are we expecting to do these things. And if I have that in mind, I can make changes to my RFC accordingly. Separately, if we want this while still keeping the daemon mode and pack intact, I can also add some compatibility. I can add a compatibility section where like pack has a pack publish command or something that allows it to. So while building things, it can store all of this extra information somewhere, and then during pack publish, it can republish some of these things out to the registry. So I don't know what what timelines we're looking at for this versus the daemon removal, what we want in the middle, and if this is still a hard block on the daemon removal or not.
I'm willing to retract most of my hard blocks on the demon removal, although I still would like to see the demon removal. Like if I was prioritizing what order to do things in, I might want to prioritize demon removal first, but I'm okay sort of like moving forward on the RFCs. I guess the point I want to discuss on this one is more about, I think you listed this in the debatable points, sort of about the distribution of responsibilities. Like, should this be a life cycle thing? Like we might be able to move forward on it even faster if it was sort of separate.
So like a pack thing?
A pack thing, or, you know, just like a separate executable that pack happens to run that another platform could run as well. Like, I think we could start building something here without changing the API. And then if we wanted to make that formally part of the lifecycle, we could bring it in afterwards. I think unlike other things, it doesn't, this is, because it happens last, something that we could freely experiment on.
I like that idea. So if this was just an independent component, that the only thing I wanted to figure out is if we could bundle it with the lifecycle container image or not, even though it's not part of the API. If we are okay doing that, I think we can easily convert it to an extension module that can be developed separately. It was just a matter of just putting it in the final image. Like a platform
The
does not.
life cycle, I guess, instead of changing the exporter API, I think we could experiment more freely if it was separate.
Yeah, I'm saying it'll be a separate binary. I'm just saying that if it's part of the image, it's one less thing that the platform has to like import and inject. So like it can be a separate binary that the platform runs after the exporter, but it's still just present in the image, and it's going to be run in the secure mode. So if it's part of the lifecycle image, that makes it easier.
The only thing I would say is, let's say from PAC's perspective, I don't know how we would be able to interact with an extension if it's not part of the API.
Why not?
Because like, I guess we could go into like, how do we know whether or not that binary is present in the builder?
I mean, it doesn't have to be present in the builder, right? Like it just has to be present in the lifecycle image. Like you can just run it as an additional last step.
Okay, I see what you're saying. Okay.
Like even if it's in the creator flow, this will be an additional container you spin up for that binary with the lifecycle image, not part of the builder.
Okay, that makes sense. Cool.
I think it could be part of the builder if we made like the extension point like a lifecycle / finalizer, and it runs things that could be on the builder or not or something. Because obviously this is just one example of something that can happen after all that's done. And then we still have to have the discussion of, does this get registry credentials and things like that, right? Because obviously for something like this cosign, you're going to need that.
Yeah. I mean, it will obviously need registry credentials. It will just be up to the platform to provide those to this binary the same way it did to lifecycle. And it will have, the platform will have to manage some like state between the creator or the other phases and this phase. So like some volume where it stores some common things.
Yeah, because you'll need to know the digest of what was just exported in the previous execution, like from report toml or similar, right? Yeah.
The only weird thing I find about this is like what happens when the platform API changes, or like what contract does the platform have with this binary? That's unknown to me. As long as like if you're just experimenting with it, it's fine. But like if we want like wider adoption with this, we'll need some contract with the platform API and this binary. And that's why I was.
Part I fear, right? Like I fear that this is going to become another project descriptor thing where we start using it, but there's no real contract around it, and we're having to walk backwards to put everything in place.
I mean, this is also why I couldn't think of a way of removing it from the lifecycle while keeping it a common platform component.
So, because I guess if it's like a pack specific thing, right, then that's different.
Yeah.
But it doesn't sound like that's what you want it to be at the end of the day, right? You want it to be something that could be reusable across multiple platforms. And then I think a lot of the same concerns come up about what's the contractual agreement, the interface between this thing and anything going forward, any other platform.
That all makes sense. I feel like there's this tension between this and the conversation we were having last week about like what are ways where we could experiment without having to approve spec changes first, right? But I wonder if, you know, could we get there in phases? Like this is an experimental feature and it's separate. When it all goes well, we'll put it in the formal API.
But I think a precursor to us going down the extensions route was like having a clearly defined extensions API that's aware of platforms and whatever APIs they are compatible with. So like it's free form in that you can do additional things, but like there's something that runs this, like something in the lifecycle or something, some translation layer that runs these extensions. If it's just purely experimental and we just want to try and experiment where we start off with a component that's just for pack and see if we can reuse it in other platforms, that's fine to me. I can reword the RFC so that it's just pack specific for now, but it's implemented in a way that it's not a hard-coded thing inside pack. If that's okay, like we can start with that goal that this is meant for pack, but it can also be reused by other platforms. And then we can see how it all plays out. Does that work? Okay. So let's keep it pack specific only in publish mode. That'll keep things easier, then we don't have to worry about the name. So pack has some additional flags. If you provide the publish mode, those flags are invoked or allowed. Pack does the validation that those extra cosine flags are only added when you are using publish mode, not otherwise. And we just switch it from lifecycle to pack with the caveat that ideally this should be reusable, or the core implementation should be reusable.
I like it.
Cool. I'll make those changes and we can get this moving.
I think we're on to the next one. Prepare phase. I don't know who's owning that one.
Yeah, I could give a quick overview of this new RFC. I know it's been in draft for some time as we were working through a couple kinks, so a lot of people probably already seen it, but some of you may not. And then additionally, certain things might have changed since then. So I'll go ahead and show a little bit of that. Let me resize this real quick. All right. So let's see, starting at the top. So this ended up being something that was very specific to trying to get the project descriptor utilized within all the platforms. There were a couple of concerns there, but at the end of the day, we ended up with this idea of adding a new operation. I want to call it an operation instead of phase because it's outside of the build operation, right? Set of phases. But essentially similar to what Sam just previously brought up about like this finalizer idea, right? Something that executes completely separate from the build operation. This is actually on, the front end, on the before a build operation occurs. There's this prepare operation. So kind of like a precursor to this is something that's not in the StartFC, but a lot of platforms, today already have some sort of preparing mechanism, right? If you look at Tecton, they do something. If you look at Pack, they do something, and so forth. So this is more or less trying to standardize that and also kind of allow for the use of the project descriptor to be part of that specific operation. So as we walk through here, some of the things that motivated this specific RFC had to do with things that may be specific to just Pack, but they were to serialize the CLI, to have a different file within the repositories, but then also for platforms to recognize the project descriptor and have some sort of ideas on how that should be used throughout different platforms, instead of just, certain platforms supporting it and others not. And so it gives a lot more guidance in that respect. This particular RFC focuses primarily on goal 3 of these motivations. So what it is 3 things: moving the IO build packs properties, so the things that used to be in there for the most part, to a IO build packs default. And I'll go a little bit more into that detail. A replaceable new phase, right? It's still a phase at the end of the day, but it's a swappable phase, meaning that platforms could put in their specific prepare operation. And then last but not least is supporting utilities that the project itself would provide. So the first one is changing the IO build packs namespace. So the primary reason for this is because I think beforehand, when we had just the IO build packs namespace, it gave this impression that as a user, right, like those properties would always be applied no matter what. And by transitioning them over to default, it hopefully conveys the idea that these are the potentially things that may be applied, but it's really ultimately up to the platform to apply those, right? And part of this prepare operation. It also then allows for this schema version or any other top level properties that we may want to add at the end of the day. That would be, outside of things that the platforms themselves operate against. Here's a, kind of example. There's not much different from the existing, the O2 project descriptor, but one of the things that did get kicked out as part of this was the builder, right? The builder, the reason why that got kicked out is because we kind of started defining the criteria for the things that would be within this namespace. And the things that are within this namespace would be things that would be inputs to the lifecycle phases, right? And the builder doesn't meet that criteria, so it doesn't make sense for it to be part of there, part of that namespace. Let's see, outside of that, we could go on to the prepare phase itself. The primary responsibility for the prepare phase is to apply the requested configuration, right? And in this case, we're talking about the project descriptor or the project TOML. We have a little bit more guidance on that below in the spec changes proposed. But for the most part, this just declares that it will run before the create operation or phase, or before the detect phase, depending on how you're operating the lifecycle. This is very similar to how Rebaser operates, right? So Rebaser is outside of the standard workflow. And in this case, it's expected to be run before the build operation. I feel like I'm repeating myself, so I apologize. Let's see, the next thing, it would be the supported utilities that the project provides. One of them would be a go prepare function. So in some cases, like let's say Pack, in order of it having to spin up a container to run this prepare operation, it'd be nice if it could do it natively in some sense. And so we'd like to see that the lifecycle library provide some sort of functionality there. Along with that, for other platforms, such as like Tecton and whatnot, it would also be nice if the project provided a prepared binary that does a couple default things. Like, for instance, downloading build packs, I think is something that we've talked about wanting for some time now. It could update the order based on the default groups. And also it could set up the environment variables into the platform environment variables directory that are defined there as well. Last but not least, something I like to see is to notify the user of any properties that might be in defaults that aren't being applied, right? Because there are some that may not be applied by default and so forth. Let's see, there's a couple alternative suggestions here. You could run through the benefits and drawbacks of each one of these. I'm not going to go too much into detail on that. And below here are the kind of spec changes. One of the things that's probably worth calling out is my proposal to move the namespace of IO build packs to the platform spec, right? So the schema version would be directly tied to the platform API version as part of the platform API. And really the project descriptor spec would only be about defining the overall structure of the project descriptor itself, and not so much any like project specific namespaces. Again, that's a very high level overview of this. Open to any questions.
I think the only question I had was the same discussion we were having last time, which is like, how does this modify flags that were passed by the platform from the things that are present in the project descriptor and given output that the platform can then pass on to the rest of the lifecycle phases?
Yeah, so I purposely left that out of this RFC, although I think it's very valid. I left it as an unresolved question. I think there is a high possibility that we could leverage something that I think Jesse brought up at some point, which is like a lifecycle config file. So if the interface was more in line with a file system based configuration, then we could do that a lot easier than what it is right now.
Given that this is a new phase or part of the platform API we're introducing, is there any reason why this cannot be driven by that lifecycle config like file? So rather than passing everything as command line flags, you create a file and pass that file to this prepare phase. It modifies it according to whatever it feels like. And that same file is then the platform is responsible for taking that file, deserializing the same struct fields it gave in, and then passing it on to the rest of the lifecycle phases.
For me, it's about two things. One is minimizing scope. There were a lot of conversations within the lifecycle config file about like the structure of it, what things make sense and so forth, that I feel like it could become its own rabbit hole of sorts. And so I'd like to keep them separate. Two is I think it makes sense to do all or nothing, right? Instead of having like one phase work differently from all the other phases, it'd be nice that when we apply this change where we have a lifecycle configuration file, that it works across all of the phases. So for those reasons, I think it makes more sense to keep them separate and, keep it in this, or, like ultimately the other option would be like, okay, this would be blocked on the lifecycle having a configuration file first. Like I wouldn't want to tie them directly or use this as a driving for that.
Because then this this in itself won't be able to completely replace whatever Pack is doing right now to prepare for the lifecycle phases to be executed, right? Like it cannot replace Pack's current implementation for picking the tags, and like does Pack support that right now, or does it not at all support that through a project descriptor?
Project descriptor? No, it does not.
Okay.
That's the image RFC that's out right now.
So if we want to support something like that image RFC, like we'll need a separate implementation for the, apart from the prepare phase, to support that, right, in Pack.
Yeah, and I think what I would be okay with is blocking more or less the implementation of sorts, or the release that this goes in a set of specs for the configuration file, right? But what I guess what I don't want to do is I don't want to balloon this RFC with saying, hey, this is now defining and bike shedding on the lifecycle configuration file. So I'm okay with, you know, if we want to strategize how to get this, you know, implemented. But yeah, I'm just kind of, again, trying to keep the scope to something else.
So actually, taking the images example, wouldn't it, because we're moving this to like defaults, doesn't it allow us to introduce that without ever actually implementing it? It's like we can introduce it to the schema, not make any statement about Pack supporting it or anybody supporting it, and then gradually have it work its way in. Like adding it to io.buildpacks.defaults is just feels like it's just making a statement about this is how you will specify this thing without you know, necessarily implying anything about the behavior of a particular platform or even the life cycle. So if that's the case, it feels like a good approach to introducing things like that.
Seems
Yeah, I
like
mean,
there are
sorry, go
two
ahead.
things here. It's like if we could create some loosely defined schema that's like similar to what we're doing with Project Tummel now, where like this will be executed eventually. But it seems like what we're getting into here is very specifically how. It's like you'll run this binary and it will write certain files. And I wonder if there are some aspects of that that would be more productive to discuss after we've fixed how we send inputs, because a lot of these inputs, like even the ones we're saying we can write as files, like order tummel, like the default location of that is not on a volume, right? You actually don't even know if you can do that this way, right? Like we sort of need to go back to Jesse's old RFC about sort of refactoring the platform API file system such that platform has a place to inject config on a volume in a way that works better in like a Kate's situation rather than in a Pack copy the files in the container situation.
Yeah, I mean, if we go back to the, I still think this provides some value, but yes, granted, it probably doesn't support all the things that we want. But like going back to the order tummel example, right? In that case, the platform could define a new location for that order tummel if it's going to modify it. And then
It supports order tummel in the layers volume right now. I added that after this didn't make it through, for what it's worth, for that same reason, so that you could write it to a volume and have it get picked up. So it is possible to load from a layers folder already, but it would be nice, yeah, if it didn't have to do that specific one-off for every file that we support in the future.
Yeah.
Yep. The other thing that, like, the other question that comes to mind here is we're talking about making this part of the platform API. But what I assume we still want to check Project Tummel into the root of an after, right? Does that mean that you cannot run the same app on two platforms that are using different platform APIs?
Not necessarily, right? It means that we now have something, a number that tells us what platform API the data structure is based on, right? Like the schema, essentially. The platform, the prepare, right, operation could do internal translations to, or just know how to read from different platform API versions, different schema versions, I should say.
I feel like in some ways I can see why that's useful, but it's making it hard to describe what the platform API is. If like what this phase is doing is translating from one platform API to another, because the shape of the outputs are going to have to be the right shape to be the inputs for whatever platform API you're running on, right?
Not necessarily, right? Unless I'm not understanding your question. But like this input, right? This namespace is the input for the prepare, no matter what, regardless of the platform API.
That's what I think is confusing. You're like, I'm using platform API 04, and I'm passing this input, which is using a different platform API. I don't love the idea that we could use two platform APIs at the same time, right? I think that just is confusing to describe, right?
I don't disagree, but I can't think of a better way. The converter essentially is the same problem, right? Or had the same problem.
I think
mean,
in some ways this is trying to be the converter, but without another number. It's like trying to reuse that same number to convert in a way that I think will be hard to describe what is supposed to happen.
I mean, if we can get that lifecycle config thing going, this prepare phase could be supported starting a certain platform API version. I mean, we can't fix what's already out there, but we can fix things for the future. And then this works as part of like with the typical lifecycle behavior that detects the platform API version from an environment variable, given that environment variable and the config file with all the arguments, it can then translate accordingly. So still has to be aware of the platform API version, but starting at platform 010 or whatever.
Might be it might be an interesting move to make this prepare read that lifecycle toml, config toml that we're talking about. So you kind of, as a platform, you either get it from your builder or create one, and then prepare could modify it, and then so forth and to all the different phases, so that is the interface. But I don't know if that makes things much easier instead of like having to take all the arguments in the same as creator. It might give you a schema that you can support or not support for your prepare phase.
That was, I think, the idea with that file, that if it's the same file, then this prepare phase can change it however it wants given the project descriptor. And that way the platform just like gives the file somewhere, runs the prepare phase, that modifies it in a way that the platform doesn't have to care about. Like it's still compatible with the same platform API. It's just that file that would have passed directly to the creator or the other phases, and then it just runs it.
Yeah, I think we're talking about two very different things, right? Like the interface for between phases is one thing, and I think all that aligns. I believe what Emily and I are talking about is the schema version and having the schema, the namespace essentially defined at the platform API level, right? And that being a challenge, and how do we resolve that? Because at the end of the day, I think it makes sense, or it's easier to say that the namespace is tied to the platform API, so that we don't have to manage or maintain two different things, but it does become a little bit confusing. The alternative to this would be to have yet a different file or a different specification, or a different schema, right, somewhere that says this is the namespace and that is versioned independently.
Isn't that sort of what we're already doing with the project toml, right?
Sort of, but I guess what I'm trying to get at is I think we should separate the project descriptor, like version from the
The
namespace.
IO build packs stuff.
Yeah.
Yeah.
Yeah,
I
you're,
could
you're proposing
definitely
two
see that.
schemas. I can see yeah, because I mean, obviously
There already
companies will
are
have
two
their own schema.
schemas
Yeah.
in that one file anyways, right? The way it's just,
They are, but not in the O2 that's going to go out. That's what I just requested to be added. But yes. So we could do that as alternatively, right? Are we in favor of that? If it'll simplify it.
I'm definitely in favor of it being a different schema version. I still don't know how I feel about it being the platform API version. But I don't think it needs to iterate with the project descriptor version.
Yeah, and I
I
think,
think it can't be the platform API version. I think it has to be different. It should just be the schema version of this file.
of this namespace,
Sections, yeah.
because no matter what, this will stay true, right? The format of must adhere to version 02, like that is tied to the platform API. So if we want to then update project descriptor to 03, right? We would then update the platform API to say now it only supports 03 project descriptor.
Now it only, what's it?
The prepare.
Prepare
The
only supports
platform.
03 of the project descriptor. Yeah, it's
What's
like
what's it
the,
consuming out of the project descriptor that isn't in this namespace?
Well, what I guess what I'm saying is that 03 could look completely different and it could be a completely different namespace. Right? Like let's say we say, screw it, reverse domain name
I
suck,
see.
right?
Yeah,
So
yeah.
brings, because that has come up.
That seems reasonable. Like, yeah, I don't know how you get around that.
like, it's too bad that we now need to say both of these versions, like which schema version of the actual data do we support and which version of this project that allows you to specify different schemas do we support. But if we're going to support Project TOML natively, I don't know how we get around it.
And that's why I was trying to shortcut this or minimize the number of versions we have to adhere to, but it is confusing. I agree with that.
The other thing that I want to like bike chat about a little bit is defaults. Like, I don't know if I totally agree with the premise that without defaults, platforms cannot accurately convey what is and what isn't optional.
I don't know that it's platforms that I care about. Right? It's the end user that I care about.
For my mind, having to throw the defaults in there makes the experience of using this file worse. And I don't know that it adds more clarity that makes up for that extra longer name of everything.
What is, yeah, I mean, I really agree with you, but I wasn't sure what other way there was to communicate it. You said you think there's a way for platforms to communicate what they support and don't support?
I think in some ways it's an exercise for the platform.
Yeah, I mean, to your point, right? Like defaults doesn't really communicate what a platform supports. All it says is like, it's the Wild West, like no telling what'll be supported. And I think what Emily is saying is like, platforms need to do that anyways. Like they need to communicate on their own what they're going to support and not support.
Because just saying it's all defaults and then having it happen and then having some of them only apply, but you have to figure out which ones they were. I think the platform still needs to be like, by the way, I'm ignoring this and using that. And
Yeah, I mean, I would very much like to cut the defaults part of it if we think that if it can work that way. I was worried if we don't have defaults, if the schema version can still work. I don't know if like mechanically there's a reason it needs to be a level up.
I think schema version just ends up being a special key, right? And that would work. Yeah, I'm more than happy to be outvoted, I guess. And if the majority says like, hey, there's no need for defaults, I am okay with that. So I'll add a little poll on the RFC with little emojis, and you can vote that way. All right, any other, okay, how about, so that was bike shedding, I get that. Any other like major concerns? I guess maybe bike shedding stuff too, we could throw in.
I think maybe on the same theme, it'd be nice to throw in some examples of like what a platform is supposed to do. If, for instance, it does not want to allow arbitrary build packs to be downloaded, stuff like that. Like I can make assumptions like, oh, before I run prepare, I should delete these things out of the file or whatever, but just sort of describe some of those workflows, I think would make this easier to visualize.
Describe the workflows, okay. More by example. So we're saying
Yeah.
things like more like this. So like this is an example, right? A usage example.
Yeah, but sort of describe. I think specifically cases where something in defaults is not being respected. Like how does a platform go about doing that if it still wants to run prepare in order so some things can be respected?
Right. Do we need flags into additional flags or invars into prepare to like disable certain functionality by default for the one we ship so that you don't do the exclude includes or you don't download build packs or things like that. Right?
Or is it the platform's responsibility to just rip out everything it doesn't like before it runs prepare? Like either way, I think it's worth having all those details in here so we can think about it.
Maybe I'm confused by that. So in most cases, like platforms would have their own prepare, right? Are you saying that you would want to think about how if a platform wants to disable a certain feature from the project provided prepare, how they would go about doing that?
Yeah, but even if it's
Okay,
not
I was not assuming that
possible,
every platform would need its own prepare, but like maybe it's just about making that clearer that this prepare is just for pack, I guess.
No, this prepare would be the default prepare. We have a prepare just for pack that I stripped out of this that I will add to the pack toggle RFC.
I guess if, as a platform, assuming I want something different than the default prepare. Why do I want this prepare to exist anyways? I'm not sure it helps me. Now I'm required to implement this in this one specific way. I guess I could already run a prepare that's different. I'm confused then. It's like who's deciding what the prepare is?
The platform is, right?
Platform is.
Yeah.
And the platform copies it in and runs it.
Yes.
So then why are we sort of like specifying an interface for it? It's like it's totally on the platform. Does that make sense?
Well, so if we look at the spec, it says that it must, right? Prepare the environmental variables, and it talks about the prepare. So it must call executable of this nature in some form or fashion. Whether it's its own, custom built, or if it's the one provided by the project, I think that's the choice that the platform makes. But it goes back to the finalizer, right? It's like, what is the contract for the thing that I plug in this specific operation? And this is the contract.
It feels confusing to me because it's not makes sense when we're defining sort of the platform's contract with the thing we're providing. It's like, here's how you give it its inputs, here's how you get outputs. It feels weird to define the platform's contract with the thing the platform's providing. Like, what if I don't want to use anything in there? must I run a prepare phase that does nothing, you know?
I guess that could be true for a lot of things though, right? For a lot of phases.
Not in
But I think
my
in those
mind.
phases, yeah, in those phases, we're looking for a standardized behavior. And I think like what we're actually looking for here is flexibility in what happens. So like in those other cases, it's about, yeah, standardizing the behavior, where here it's actually about not like not requiring anything.
I think the idea was that since we wanted the prepare functionality to be consistent across platforms, the platform could easily choose to reuse the same prepare that Pack has, or the default prepare from some other place, and not implement it by itself. Like if Pack wants to reuse the prepare that KPack has because you want a more strict version of prepare than what Pack supports by default, you can do that. So that was the motivation behind having a standard interface for prepare, just portability across platforms. You can create your own one if you want, but if you want to get the same pre-processing across different platforms, then you can use the standard interface, and like you can use something that some other platform could for itself. So rather than it being tied to the platform, it's like what kind of an audience that platform is aiming for. Is it more of a secure lockdown version, in which case like you want it to run on Tecton, on KPack in that exact same way, and the default pack one is just like fully flexible, meant for app developers who are pulling in random build packs. And if you wanted that in, let's say Tecton, for example, you could do that. Like we've had requests at some point, you're like, I want to download build packs dynamically like Pack does, but I want to do it in some other platform. It was more to satisfy these kind of use cases where a bunch of platforms want to do the same pre-processing of the inputs.
Right. So it's the portability aspect of it, right? That we're really trying to aim, and in order for it to be portable, we need to have some sort of specification around it, some sort of contract around it.
We have 10 minutes left. I feel like I haven't had a chance to do a full read through of this. I think that would be helpful for me. So I'm wondering if we should take a step back, let folks read it, and then revisit again. I don't know. I mean, y'all tell me if that makes sense. Okay, thanks. The next thing on the agenda is the profile build pack, and it says check with author. I'm not sure what's implied here.
I think we're just putting it on there because it looked like it was updated somewhat recently, but maybe that was just a comment from you. It's only a 10-day-old RFC, and the author may not be here, so we wanted to know if anyone knew anything about this and how to move it forward and what needed to happen.
Yeah, it looked like there was activity. I'm tracking it at least.
Okay, great. As long as it's being tracked and no blockers.
Yeah, I'll make sure. I mean, I was really glad to see this because I thought I was going to have to write this RFC. So I'll help make sure that it gets through.
Yeah, I'll leave some comments from the back team's perspective since you'll be the ones maintaining it, but I am not so sure about the proposal to download bash as an executor.
Oh, yeah. I think a couple of us were saying like that's a cool idea, but like we should punt on that.
Okay.
You know. Yep. Okay. Yeah, take a look at that. Next one is annotations.
This was again something I just wanted to discuss. So like, I know Emily, you left the comment that we should expose like a generic API for build packs to set these annotations. We should also do that. I'm not saying no to that. The main motivation behind this RFC was there's two files right now which directly map to these OCI annotations. So there's the project metadata toml, which is provided by the platform. It's not the project toml. It's something else that injects other metadata about the project. So things like the git, commit, SHA, and other things. And there's the project toml itself. There are, I don't know if this was intentional or not, but almost all of these fields directly correspond to the OCI recommended annotations. Now, given the fluidity around project descriptor and the other file being a platform level file, there's no way that a build pack will be able to access that data. So things like the git revision, for example, let's say the platform is downloading some Git repository and then mounting a subfolder for the build packs to take a look at, which doesn't have the Git folder. There's no way for the build pack to extract that information and put it somewhere. Same for all of these other platform level features. Like build pack can potentially read a project descriptor and try to construct all of these, but then we go back to the same issue, which is like now the build pack has to be aware of all the different project descriptor versions. So that's why I was like, can this just be a platform thing? Platform already has to process the project descriptor in some way. It already outputs everything to project metadata toml anyway, which is a platform specific file, and those map out directly to these OCI annotations. And if that was not the intention behind these fields initially in the project descriptor and project metadata toml, then like I'm missing some point here. Like why were those fields added in a platform specific file?
When you describe all those things, it makes me feel even more strongly in some ways like it should be a build pack that's doing this. Like I think doing those things in the platform API with project metadata in many ways was a mistake, because now you're getting like variable behavior based on what platform API your platform is using. And it's harder to iterate on. And if we could instead push this into a build pack that reads project toml, and then the build pack could easily handle multiple versions of project toml in a way that's less cumbersome than the lifecycle doing it. I think it would be nicer, and we could just like try to cut out project metadata. Like the git rev is maybe something that is a little bit weird, but you could think of ways for the platform just to pass that to a build pack if it knows it's there, or work with a collaborating build pack. Like I think it's a classic utility build pack, like slam dunk.
Yeah. I mean, definitely if you phrase it as a utility build pack, it makes sense. Like as long as it's provided by the project, it makes sense. But we'll now have to figure out a consistent way for the platform to pass like these source metadata fields to the build packs.
The utility build pack can like document its own API. Like we could take it out of the world of things that's hard to change and put it in the world of things that's easy to change. And I think,
yeah, I mean, you can pin your build pack version if you never want to update your platform again. Like if you're just happy with it, you just never have to update that build pack. And it's, yeah, I don't know. I like moving the contract out of lifecycle here.
So my main motivation for this RFC was for anything to be built by the build packs project, by lifecycle, to have all of these fields, which are well known as part of its output. Like no matter what you're using, if you're using the build packs project, we'll pre-populate these standard fields for you. The other issue is fields like the base image annotations. Like now we'll have to figure out a way for the platform to dynamically pass in the final run image it's planning to use. That may not even be available to it. Like if you're going down that whole support Docker files route, I don't know how that whole thing will play out.
My mind is very similar to labels, right? Where like build packs can set arbitrary labels.
Yep.
The platform, the lifecycle also sets some labels, but the
Yep.
only labels it sets are ones that it like functionally needs in a lot of ways. So if it's a lifecycle specific concern, I think the lifecycle can still end up setting annotations, but if it's something more cosmetic like this, I'd love to push that into a build pack. And then, you know, if it's a utility build pack, if it's a system build pack, we can create that atmosphere where it's just always running, but also give people a chance to replace it or upgrade it or disable it in an easy way that doesn't involve like a bunch of lifecycle flags that are about minute behavior. Like the lifecycle should be dumber, I think, and build packs should be smarter.
But we already violate this, right? We already introduced the project metadata stuff, which lifecycle doesn't ever need. And the lifecycle already reads that file and puts it out as labels.
Yeah, we definitely do this weirdly and incorrectly in a bunch of places, but this is the vision I want to push us towards that I think is better than where we started. It's like, that's why we just approved all these utility and system build pack stuff so that we can do this. We can go in this direction that I think will put us in a better place.
I mean, I'm happy to move out the annotations stuff to a build pack API. I still don't have an answer for how a build pack will actually set all of these annotations because it doesn't have access to that data. I'm completely fine with build pack setting these values for the things it can read, but there are simply some values that it cannot. Like the final base image that's used, that's probably going to be something that the exporter knows.
Yeah, for stuff like the base image, I think it has to be the exporter, right? But
Yeah.
for things like author and homepage and stuff like that.
Those are completely fine, but like, so can we keep project metadata as it is, like not add any new fields to it as I was proposing in the RFC, that copies things over from project DOM to project metadata. But for the things in project metadata, we map them out from, we remove them from the labels and move them to the annotations. Does that make sense? So like project metadata right now just consists of these kind of fields, which probably cannot be set by a build pack anyway.
Apologies, my doorbell is ringing and I have to get this. I'll be back.
That was her way of saying no.
Any of the implementation maintainers have any opinions on this?
I don't know. I really like the idea of it being a utility build pack, but I understand that there's just some things that you won't be able to do if you implement it that way. And also, I do see your point of like any build pack created and then suddenly having all these is like a nice project sort of perspective. Like every build pack image has these annotations, which is nice. But I don't know. I don't have a strong opinion, but I think I still lean towards it being build pack and just dealing with limitations and making those limitations less of a factor long term. Like if there's things we really want to have in that utility build pack, we use that as a forcing function to improve the API or make these utility functions have a bit more meat to them if need be.
Yeah, it's like how can we shape the interface between those utility build packs and everything else so that it's like highly orthogonal, you know, in an effort to limit the complexity of the life cycle and things like that, but still give more power to the utility or system build packs, whatever constructs we have.
Because I mean, I'm completely fine with this being a build pack API thing. It's just that I cannot foresee any way for the build pack to know the final run image, for example, especially with the proposals for that support Docker files RFC going in. Like there were proposals for the run image extensions to run parallelly with the build process, because the build process actually doesn't need the run image. And then at the end, when you get to the exporter phase, that's where you block on the build pack build process, the image extensions, and then run the exporter. Like for any case where we're doing anything that's platform level, or like build pack doesn't know it's running in a container. It will never know that.
It feels like an extension, like most of, like I said, if we had a build pack that did annotations, that's fine. But then maybe in addition to that, some of our talks around having extension points for lifecycle, like before exporter, but after builder, another optional extension point is provided that takes in all the exporter arguments so that you can then lay down some annotations on the file system. They then get picked up by exporter. Yeah.
So apologies, we are at past time actually. So I want to give folks a chance to kind of wrap up the conversation so we can bounce, but we didn't get to the daemon removal. Should we pick up daemon removal maybe at office hours if folks can be there?